to the discussions of the past year questions. This video we shall discuss about the further mechanic, paper 3, May-June 2021, paper 31. Let's take a look at the first question. A particle P of mass 1 kg is moving along a straight line against a resistive force of magnitude 10 square root of V divided by 10 plus 1 square, where V meter per second is the speed of P at time t second when t equal to 0, V is equals to 25. Find an expressions for V in terms of t. Okay, so this is the resistive force. That means the negative Fr is equal to Ma. You only have resistive force. So you have a negative 10 square root of V divided by t plus 1 square is equals to the M is a 1. So you want the V in terms of t, so your A will be dV dt. It will be this. Using the separable variables, you get this 1 over sub V. Integrate dV. It will be negative 1 over 10 over the t plus 1 square dt. Then over here, if you integrate it, you will get 2v power half is equals to the 10 over the t plus 1 plus c. Just integrate both sides. Then when the t equal to 0, your v is equal to 25. So this is given in the questions. So you have a 225 power half is equals to the 10 over the 1 plus c. That will give you the c as a 0. Okay. So since we have the c as a 0, then you just replace the c equal to 0 back to this equation. Then now we want to find v in terms of t. So just need to bring the 2, divide, then you square both sides. At the end, you get v is equal to the 5 over the 10 plus 1 square. You can just leave the answer like that, or you can expand, make it become 5 square, become 25. Done. That will be the answer for the question number 1. Okay, so now we move on to the question number 2. Okay, now we take a look at question number 2. A hollow hemispherical bowl of radius A has a smooth inner surface and is fixed with its axis vertical. The particle P of mass M move in a horizontal circle on the inner surface of the bowl at the height x above the lowest point of the bowl. The speed is square root of 8 over 3 GA. So the shape look like this. Okay, so you have a bowl, hemispherical bowl. Okay, then you have a particle P moving in the horizontal circle like this, and the radius is A. Okay, radius is A, and you're moving with the speed of the V is equal to the square root of 8 over 3 GA. Okay, so what you need to do, of course, there's one more thing I didn't mention. This is the x. Okay, you are at the height of x above the lowest point of the bowl. Okay, so we need to figure out the radius over here. We need to figure out the radius over here. Okay, so now first of all, we need to find the radius r. So we will call this as a theta. Let me just call this as a theta. So first of all, your r is equal to the a sine theta. Okay, then your cos theta, if you look at the triangle, r equal to a sine theta, and your, okay, let's take this triangle out. This is the theta. This is the A. This will be A minus X. Okay. So you can see that our cos theta is actually A minus X over A. Whether this information is useful or not, okay, this is divide A. Whether this information is useful or not, we are not so sure. But it's okay. We just write it down first, just in case we need to use it later. Now, if we consider the vertical forces, vertical component, then you will have this is the particle. You can see that this will be the theta. This will be the mg. This will be your r. Okay, if you consider the vertical component, you will have r cos theta is equal to mg. Okay, I do not know the r. I also do not know the m. I also do not know the theta. Okay, then if you resolve the forces horizontally, you will have the centripetal force r sine theta is equal to the mv square over a over r. Okay, so your u, they give you the u over here. I use v. Okay, maybe I should use v. So over here they give you the v as a square root of 8 over 3 ga. Okay, so just simplify it. You have r sine theta equals to the m 8 over 3 ga divided by the, just now the r is a sine theta, right? Just now the r is a sine theta. So you can see that the a can cancel off. Then you will have r sine square theta is equals to the 8 over 3 mg. Okay, so this is what you have. So the questions are looking for x in terms of a. Okay, x in terms of a. So we just need to put the number 1 and the number 2. Okay, we call this one number 1 and number 2. We take the number 2 divided by number 1. You will have r sine square theta over the r cos theta is equals to the 8 over 3 mg divided by mg. So the mg can be cancelled off. So the mg can be cancelled off. Then you will have r also can cancel off. You will have 3 sine square theta equal to the 8 cos theta. We have a trigonometric equations. Make this become 1 minus cos square. Okay. Then expand, simplify, you will have trigonometry quadratic equations. So this one will be a plus 8 cos theta minus a 3. So you have 3 cos theta and theta plus a 3 minus a 1. So your cos theta equal to 1 over 3. Your cos theta equal to negative 3. This one you need to ignore, because your cos theta cannot be greater than 1 or less than negative 1. Okay, then now we can use this. Just now I wrote this one down right earlier. Cos theta is equal to the a minus x. So a minus x over a is equal to 1 over 3. 3a minus a 3x is equal to a. Therefore, your x will be 2 over 3a. Done. That will be the answer for the question number 2. Okay, so now we move on to the question number 3. Okay, now we take a look at question number 3. One end of a line elastic string of natural length A and the modulus of elasticity kmg is attached to a fixed point A. The other end of the string is attached to a particle P of mass 4m. The particle P hangs in equilibrium a distance x vertically below a, show that k is equal to the 4a over x minus a. So for these questions, we can have a diagram here. This is the tension, and the weight is 4 mg. So if you resolve the forces vertically, you have the T equal to the 4 mg. If you are using Hooke's law, it will be the lambda. The extension over here, this is x, so the extension is x minus the original length a. This is the a. Then you get a 4 mg. But the question giving you lambda is a kmg. We just change the lambda become kmg. Cancel the mg. Therefore, you get the k is equal to the 4a over x minus a, shown. That is the answer for part A. Move on. Part B. In addition, particles of mass 2m is now attached to P, and combined particle is released from rest at an original equilibrium positions of P. When the combined particles have descended 1/3 distance, the speed is 1/3 square root of Ga. So now, this is the original length. This is the original equilibrium positions. Now, after you combine to get the 6 mg, because 2 mg and 4 mg add together, you will have 6 mg. You will have descended 1/3a. Okay, so this is what we have. Then the speed at the beginning, this is a rest. Then when you reach over here, your speed has become 1/3 square root of Ga. So first of all, we need to find the extension. The extension at the very beginning is x minus a. The extension when you reach to the, when you descended the 1/3a, it will be the x plus 1/3a minus a. Then you will get x minus 2/3a. So these are the things that we have. The height is 1/3a. Okay, so now we can just use conservations of energy. We will be having the GPE loss is equal to KE gain plus the EPE gain. GPE loss will be mgh, 6m times g times h plus equals to KE gain. It will be half of the 6m. The v square will be 1/9 Ga minus a 0 plus the EPE gain. It will be lambda. Lambda is a kmg. The 2L, 2A, x2 square minus the x1 square. Okay, so this is what we have. So we cancel the mg, cancel the mg, cancel the mg. We will be having 2a is equals to the 1/3a. The k over here, we just replace it with this value. So we will get this one as the 4a as a plus here over x minus a over 2a. Then inside here, you expand. You will get x squared minus a 4/3ax plus 4/9a squared plus a minus a x squared plus 2ax minus the a squared. Cancel this. This one you join together, you get 5/3a equals to the 2/x minus a. This one, it will be 2/3ax then minus the 5/9 a squared. Okay. Yeah. Then we can cancel the a. You will get this one as the 5x minus a equal to the 6 of the 2/3x minus the 5/9a. Okay. So we just expand this. You can get this one as the 4x minus the 10/3a is a 5x minus a 5a. You have x is equals to the 5/3a. Done. This will be the answer that you have for the B. Okay, so this is how we get the answer x in terms of A. Just like that, done. Move on. We have question number 4. Now we take a look at question number 4. We have a diagram here. A uniform solid circular cone has a vertical height of kh and the radius r. A uniform solid cylinder has a height h and the radius r. The base of the cone is joined to one of the circular faces of the cylinder so that the axis of symmetry of the two side solids coincide. The cone and the cylinder are made from the same material. That means they're having a same density. Show that the distance of the center of the mass of the combined solid from the base of the cylinder is h multiplied k squared plus 4k plus 6 over 4 multiplied 3 plus k. So for these questions, usually we just build the table. Okay. So we have the solid. This is the cone. Then this is the cylinder. Okay. And we have a combined solid. Okay. Since they are having a same material, we just need to consider the volume we'll do. No need to use the mass. So we need to find the center of the mass from the base of the cylinder. So we're looking for bar y. First of all, the volume for the cone. Volume for the cone, this volume for the cone, V1, is actually the 1/3 by r square h. The volume for the cylinder is by r square h. Okay, so over here we can just write it as a 1/3 k by r square h. This one is a by r square h. So the combined particle, we can just combine them together to get it as a 1 plus k/3 by r square h. The center of the mass from the base for the cone is the h plus 1/4kh. You can make it become 1 plus 1/4k multiply h. Then for the cylinder, it's just only half of the h. Okay, so the table is done. Now we can find the bar y by taking the moment about the base of the cylinder. So you will have 1/3 by r square h multiplied by this plus this equals to the 1 plus k/3 by r square h bar y. All the by r square h can be cancelled. Then you combine together, you get a 4 plus k/12 h kh, sorry. I miss out the k. There's a k here. Okay, there's a k here. Sorry. This is a 1/3 k by r square. So I miss out the k here. There's supposed to be a k plus the h over 2 is equals to the 3 plus k over 3 bar y. Okay, so we can join all together by making this as a k square plus 4k plus 6 over 12 is equals to the 3 plus k over 3 bar y. So therefore your bar y is actually h k square plus 4k plus 6 over the 4 of 3 plus k shown. This is the formula. This is the expression that they want you to show, just like that, done for the part A. Okay, now moving on, part B. The solid is placed on the plane that is inclined to the horizontal at an angle theta. The base of the cylinder is contact with the plane. The plane is sufficiently rough to prevent sliding. It is given that h is equal to 2r and the solid is on the point of toppling when the theta is equal to the 4 over tangent theta is equal to 4 over 3. Find the value k. So over here we have a diagram. We have an inclined plane, theta, and we put the object on the plane and they are at a point of toppling. So we all should know that when you're at a point of toppling, it will pass through the corner over here. And this is the theta as well. We know that this is the bar y. We know that this is the r. Okay, so this is the situation that we have. So from the diagram, we can see that the given tangent theta equals to the 4 over 3. But from the diagram, we know that the tangent theta is r divided by bar y is equal to the 4 over 3. That means we get 3 r is equal to the 4 bar y. Okay, but before that, we need to settle this part first. Okay, so to settle this part, we need to let h equal to 2 over 3r or r equal to the 3 over 2h. Okay, so either one, either one of the way. So over here, we also given 3h is equal to 2r. Either we make the h become 2 over 3r or we make the r become 3 over 2h. Okay, so it depends on how we want to solve it. Okay, so we just put it aside first. Then the bar y, based on the result that we have in the part A, we can just change it to become 3r is equal to the 4. The bar y just now is h multiply k square plus 4k plus 6 divided by 4 of 3 plus k. So over here, we can cancel the 4. We can have, okay, we can make the r equal to the 3 over 2h. Okay, making this. So the r over here, make it become 3 over 2h is equal to the h k square plus 4k plus 6 over the 3 plus k. So the h can cancel off. Then you can have 9 multiplied 3 plus k is equal to 2 times of k squared plus 4k plus 6. We try to get rid of the fractions, try to get rid of the denominator. So you have 27 plus 3, 9k. Then is equal to 2k squared plus 8k plus 12. You get a 2k squared minus the k, and then minus the 15 equal to 0. We try to factorize it. So we have a 3, we have a 5 here, minus and plus. The k is negative 4, 5 over 2, and the k equal to 3. Okay, we will ignore the value for k that is negative. So therefore, your k is 3, just like that. So this will be the answer for the question number 4B. Moving on, we have question number 5. Okay, now we take a look at question number 5. A particle P of mass M is attached to one end of a line in an extensible string of length A. The other end of the string is attached to a fixed point O. The particle completes a vertical circle with a center O. The points A and B are on the path of P, both on the same side of the vertical through O. OA makes an angle theta with the downward vertical through O, and OB makes an angle theta with the upward vertical through O. The speed of P when it is at A is U, and the speed of B when it is at B is AG. The tensions in the strings are at A and B are TA and TB respectively, and it is given that the TA equal to the 7 TB. Find the value of theta and find the expressions of U in terms of A and G. Okay, so over here a diagram is needed. So we are having a string over here. This is the O, this is the A, this is the B, this is the theta, this is the theta. This is the tension A, this is the tension B. When you are at A, your speed is U. When you are at B, your speed is square root of AG. Okay, so for this question, very obvious, we can start directly from conservations of energy. We have the GPE gain is equal to the KE loss. So it will be mgh equals to the half m of the u square minus the v square. Okay, so we can cancel the m. We can have the v square is equal to the u square. Over here, we will use a u square. Okay, we will have a u square is equal to the v square plus 2gh. The v is already given. This is the v. So it will be ag plus the 2gh. So the h is over here. This is the h. So the h is actually a cos theta plus a cos theta. So you actually have ag of 1 plus 4 cos theta. That is your u square. Equation number 1. Okay, other than using conservation of energy, now we can consider the tension at A. The tension at A, you can have the mg here. Okay, this is the theta. So if you resolve the forces to the center of the circle, you will get d dA minus the mg cos theta is equal to the mu square. Okay, so you will get the dA mu square over A, centripetal force. Let me write properly. You get the dA is equal to the mu square over A plus the mg cos theta. Then at B, if you resolve the forces to the center of the circle, you will have the dB plus the mg cos theta is equal to the mv square over A. Then your dB is actually the v square is ag minus the mg cos theta. That will be mg 1 minus cos theta. Okay, that is your dB. Okay, so now given dA is 7 dB. That means we are having mu square over A plus the mg cos theta is equal to the 7 mg 1 minus the cos theta. Okay, so we cancel the m. Cancel the m. Then we get this as the square plus the m plus the GA cos theta is equal to the 7G. I forgot to cancel all the m. 7G minus the 7G. Forgot to write down the A as well. 7GA minus a 7GA cos theta. So you have a U square is equal to the 7GA minus the 8GA cos theta. Okay, so I will call this one equation 2. Let the equation 1 equal to equation 2 because equation 1 over here is also U square. So we just put it together. You have a GA 1 plus 4 cos theta is equal to the GA 7 minus 8 cos theta. GA cancel off. So you get 12 cos theta equal to 6. Cos theta equal to half. Therefore, your theta is equal to 60 degrees. So we found the theta, 60 degrees. Okay, we have found the theta. Now we want to find the U in terms of A and G. So since you have found the theta, just put into the equation 1. Over here, you can find the U. Okay, so from the equation 1, your U square is equals to the GA of 1 plus 4 cos theta. Then you get this one as the U is equal to the square root of 3 GA. Just like that, done. So this will be the answer for the question number 5. And moving on, we have question number 6. Okay, question number 6. Two uniform spheres A and B of equal radii each have mass m. The two spheres are each moving with the speed u on the horizontal surface when they collide. Immediately before the collision, A's directions of motion makes an angle alpha with a line of centers, and B's directions of motion makes an angle beta with a line of center. See the diagram. Okay. The coefficient of restitution between the sphere is 1 over 3, and given that 2 cos beta is equals to cos alpha, show that the directions of motion of A after the collision is perpendicular to the line of center. Okay, so we will need to draw the diagram before and after. So before, let me just put it this way. This is the U, this is the alpha. Okay, then this is the beta. This is also the U. Before and after. Before. Then after, I will assume that they are moving in this direction, where this angle, I call it theta A, and the speed is VA, and this one is a VB, and the theta is the angle is a theta B. Okay. So I need to show that the directions of motion of A after the collision is perpendicular to the line of center. That means I need to show that the theta A, at the end, the A will go this way. Perpendicular. This is the line of center. Okay, the line of center is over here. So I want to show that the VA go like this. That means I need to show that the theta A is 90 degree. Okay, I need to show theta A is a 90 degree. So at the moment, I cannot say it's 90 degree. I need to show it's 90 degree. Okay, so with all this, now we are ready. So first of all, you consider the horizontal component. Okay, so if you consider the horizontal component, we will be using the PCLM, Principle of Conservation of Linear Momentum. Okay, so you have a mu cos alpha. Okay, so I have a mu cos alpha minus the mu cos beta is equal to the mva cos theta A plus the mvb cos theta B. Okay, that is the first thing I need to show. Cancel all the U, cancel all the M. So I get the VA cos theta A plus the VB cos theta B is equals to the U cos alpha minus the U cos beta. I call this one equation 1. Then after that, we can consider the NEL, Newton experimental law, says that the 1/3 is equal to the negative of the VA cos theta A, VA cos theta A, minus the VB cos theta B, divided by the U cos alpha plus the U sine beta, plus the U cos beta. Okay, so over here, I will get the VB cos theta B minus the VA cos theta A is equal to the 1/3 U cos alpha plus 1/3 U cos beta. I call this equation number 2. Okay, now if you want to consider the A, just take the equation 1 minus the equation 2. We try to ignore the B. So take the equation 1 minus the equation 2, you get a 2VA cos theta A. Okay, then the right hand side, if you minus it, you will get the 2/3U cos alpha and minus the 4/3U cos beta. Okay, so this is what we have. Given the condition given in the question is that the cos alpha is equal to 2 cos beta. The cos alpha equal to the 2 cos beta. Okay, that means your 2VA cos theta A is equals to the 4/3U cos beta minus a 4/3U cos beta. So you can see that it's a 0. Cancel it, you get a 0. That will give you theta A equals to the 90 degree. Okay, so therefore, directions of A after the collision is perpendicular to the line of center. Done. Shown. Okay, so this is how we show that the directions of A after the collision is perpendicular 90 degree to the line of center. Okay, now we move on. We want to find the total KE of the sphere. They say that the total KE of the sphere is 3/4 mu squared. They want to find the value of the alpha. Okay, so for these questions, since it's involving energy, I need to find the VA and the VB. So for the VA at A, so I have the VA sine. Oh, okay. I want to consider the vertical component. I haven't considered the vertical component first at A. So at A, the vertical component is this. Is the vertical component. Okay. We know that this one doesn't involve in the collision. So before and after is the same. So the VA sine theta A is equal to the U cos alpha. Okay. So the VA sine theta A is equal to the U sine alpha. So since the theta is a 90 degree, since we already know the theta A is a 90 degree, so we have the VA as a U sine alpha. Okay. Then at B, B, we need to do something first because I do not have the VB yet. So, okay, never mind. At B, if you refer to the vertical one, it will be VB sine theta B equal to the U cos beta. Okay, we're not able to do anything with this, so we just leave it at the moment. Then at B, we can make use of the equation 1 and 2. We just take these two plus together, 1 plus 2. I get a 2VB cos theta B plus together. Then you will get this as the 4/3U cos alpha minus 2/3U cos beta. Okay, so you get 4/3U cos alpha minus a 2/3U cos beta. So again, given cos alpha is a 2 cos beta, stated in the question. So your 2VB cos theta B is equals to the 8/3U cos beta minus the 2/3U cos beta. Simplify it, you get your VB cos theta B is equals to the U cos beta. Okay, this is what we have. So I call this one 3. I call this one 4. I call this one 5. Okay, so my take the number 4 square plus the number 5 square, I will get my VB square. My VB square is a U cos beta square plus the, sorry, I make a mistake. This is a sine. This is a cos. This is a sine. This is a cos. So at the end, you get a U square. Okay. Then your VA square, just only the 3 square only. So given the KE final is equal to the 3/4 mu square. So it will be half m VA square plus the half m VB square is equal to the 3/4 of mu square. So just replace the value inside, you get half m of the U sine alpha square plus the half m U square equal to the 3/4 mu square. So you get the U square, all the U square can be cancelled off. So at the end, simplify it, okay? You can get the sine square equal to the half. So your sine alpha is equal to 1/2. We only consider the positive value because the angle is acute. So therefore, your alpha is a 45 degree. Okay, just like that. So this will be the answer for the number 6, part B. Okay, now we move on for the question number 7. Okay, question number 7. A particle P is projected from O on the horizontal plane and move freely under gravity. The initial velocity of P is 100 meter per second at an angle theta above the horizontal. Tangent theta is 4/3. The two times of P which the height is above the plane is h meter, differ by 10 seconds. Differ by 10 seconds. Okay. So over here, we try to understand the situation. Okay. You're moving like this. Okay. So you are moving up with the angle of theta. Okay. They giving you tangent theta is equal to 4/3. From here, we can draw a small rectangle triangle. 4 here, 3 here. Pythagoras theorem will give you a 5. You are moving with the speed of 100 meter per second. Now, at a certain time, let's say called T1, your height is h meter. And above, okay, at this portion, you are above the h meter. Okay, you're above the h meter. And then when it comes to T2, okay, so they say that the time gap is a 10 second. Okay, so that is a meaning, which means the T2 minus a T1, it will be a 10 second. Okay, so this is something you need to take note. Okay, we shall write it down again later. Now this diagram is for you to refer. So for this question, since it's involving time, I will use the horizontal displacement and the vertical displacement. So my horizontal displacement is 100 cos theta t, and the theta, I will be using this theta. Then my cos will be 3/5. So this one will be 100 3/5 t. Then you will get x is equals to the 60t. Then vertical displacement, my y is 100 of sine t minus the 5t squared. Simplify it, you will get 80t minus the 5t squared. Okay. So when the y is equal to h, so you have a h is equal to the 80t minus a 5t squared. So you have a 5t squared minus a 80t plus the h is equal to 0. So you can see that if you solve these equations, this is a quadratic. This is a quadratic. Okay, it's a quadratic equation. So if you solve these equations, when you find the root, your answer will be D1 and D2, right? Because this is the root. This is the time that you reach to the height of the h. So your height will be D1 and D2. So we should have learned in our further pure maths paper 1 that the sum of the root, okay, let D1 and D2 are, which means the D1 plus the D2 is actually 80/5, which is a 16, right? Then the D1 times D2 is the h. D1 times D2 is the h. Okay, so from here we get these two relationship. Agree? Okay, so from here we get this relationship. Your D1 times D2 is the h. That is your first equation. That is your second equation. And the questions give you the D2 minus the D1 is equals to 10. That is your third equation. Just taking the first equations plus the second equations, then you will get 2D2 is equal to 26. You will get the D2 as a 13. Then from the equation number 1, your D1 will be a 3. Okay, so this is how you find the two times D1 and D2. Therefore, your H is equals to the your H is equal to the D1 times D2. Sorry, not H. I write wrongly. Supposed to be H divided by 5. I make a mistake. H divided 5. So the H divided 5 is equal to the D1 times D2. So your H is equal to the 5 times the D1 times D2. Then you get the answer as 195 meter. Done. That will be the answer for the part 1. Okay. Now we move on to the part B. They want you to find the magnitude and the directions of the velocity of 1 second before it strikes the plane. Okay. So we need to know when it strikes the plane. So we just take down the X is just now the horizontal component and the vertical component is just copied down from the previous questions, part A. We need to find the X dt and the dy dt, okay, because of we need to find the velocity. So the dx dt is a 60. The dy dt is a 80 minus a 10t. So we now want to know when it will strike the plane. When the y is equal to 0, 80t minus a 5t squared is equal to 0. Take the 5t out, you have this. So the t equal to 0 and t equal to 16. This one ignore. 1 second before it strikes the plane, that means the t is equal to 15. Okay, 16 seconds it will hit the plane. Then now we want to go for when t equal to 15. 1 second before it strikes the plane. Your dx dt is still 60. Your dy dt, it will become 80 minus 150, it will become negative 70. Okay, so your velocity at this time, or the speed to be more precise, dx dt squared plus the dy dt squared. So you just use your calculator, 60 squared plus a negative 70 squared. Over here, we're not able to give the answer in a exact value form, so we just give the answer as a 92.2 meter per second. Okay, we just give it as 92.2, a 3 significant figure with 2. Then your direction is your tangent theta is equals to your dy dt over the dx dt. That will be equal to the negative 70 over the 60. That will give you the theta. The negative means what? The negative over here means that you are going below the horizontal or going downward. Okay, so you will get the answer as just wait for me to press the calculator. 49.4 degree. Okay, 49.4. Yeah, 49.4 degree. And then just mention is going downward. Okay, the negative means downward. Just like that. So this is how you get the directions. Magnitude. Magnitude means we just only want the speed only, magnitude of the velocity. Okay, so that will be the answer for the question number 7B. And that's all. This is the last questions for this paper. So I stop the video. I'll see you then. Bye-bye.